This tutorial introduces the Caesar cipher, an ancient encryption technique dating back to Julius Caesar's time. Through a simple script, users are prompted to input a message and specify a shift value, determining how many positions each letter in the message should be shifted down the alphabet. The script demonstrates the algorithm's implementation in Lua, using string manipulation and ASCII character codes to achieve encryption. By exploring the Caesar cipher, learners gain insight into fundamental encryption principles and the historical significance of cryptography in securing sensitive information. First, we will prompt the user to enter a message and a shift value using IOWrite and IORead functions. Next, we will convert the input shift value from a string to a number using toNumber function. Prompting for the shift value in a Caesar cipher allows users to customize the level of encryption applied to their message. The shift value determines how much each letter in the message is shifted down the alphabet, thus altering the encryption. By prompting for the shift, users can choose the level of security for their message. Using toNumber is necessary because IORead returns a string value by default. However, for numerical operations, such as determining the shift value, we need to convert this string to a numerical data type. toNumber accomplishes this conversion by converting the string input into a number, allowing us to perform mathematical operations on I. We will initialize an empty string in the variable encrypt to store the encrypted message. This keyword signals the start of a loop. I equals 1, we initialize a loop control variable I with the value 1. This variable will be used to track the current iteration of the loop. #message, the hashtag it is the unary operator in Lua and calculates the length of the message string. So unary operator in message returns the number of characters in the message string. Do marks the beginning of the block of code to be executed in each iteration of the loop. So, the loop iterates from 1 to the length of the message string, unary operator message, inclusive. In each iteration, the loop control variable I takes on the values 1, 2, 3, up to the length of the message string. The sub function is used to extract a substring from the message string. It takes two arguments, the starting index and the ending index. In this case, both the starting and ending indices are I, which means we're extracting a single character from the message string at index I. So, in each iteration of the loop, the shift variable will contain the character at index I of the message string. This allows us to process each character of the message string one by one within the loop. If cipher greater or equal to A and cipher less or equal to Z, then this line checks if the character cipher is a lowercase letter. Cipher greater or equal to A checks if the character cipher comes after or is equal to the lowercase letter A in the ASCII table. Cipher less or equal to Z checks if the character cipher comes before or is equal to the lowercase letter Z in the ASCII table. Together, this condition ensures that cipher is a lowercase letter. Cipher byte. This method returns the ASCII value of the character cipher. Cipher byte -97 plus shift %26. This part performs the encryption by shifting the ASCII value of the character cipher. Cipher byte -97, subtracting 97 normalizes the ASCII value of cipher to the range 0 to 25, assuming cipher is a lowercase letter. For example, if cipher is A, its ASCII value is 97, so cipher byte -97 evaluates to 0. Shift. This is the amount by which the characters are shifted for encryption. %26. This ensures that the result stays within the range 0 to 25, which is important for wrapping around the alphabet. For example, if shift is 3 and cipher is C, ASCII value 122, the result of 122 to 97 plus 3 would be 28. But %26 ensures it wraps around to 2, corresponding to B. String.char, this method converts a number to its corresponding ASCII character. The result of the encryption, after the modulo operation, is added to 97 again to bring it back to the ASCII range of lowercase letters. For example, if the result of the encryption modulo operation is 2, adding 97 will give 99, which corresponds to the ASCII value of C. In summary, this line takes a character cipher, shifts it by the value of shift, ensures the result stays within the range of lowercase letters, and converts it back to a character. Next, we will repeat the process for uppercase letters using an else if statement. Similar to the lowercase, this time we will add 65 to the result to bring it back to the ASCII range of uppercase letters, and then convert it back to a character. ASCII lowercase a is 97. ASCII uppercase a is 65. The line encrypt equals encrypt double dot cipher is used to build the encrypted message gradually as we iterate through the characters of the original message. Here's what it does. Encrypt, this variable holds the encrypted message. Double dot, this is the concatenation operator in Lua. It appends the value of cipher to the current value of encrypt. Cipher, this represents the character that has been encrypted in the current iteration of the loop. So, each time we encrypt a character, cipher, we append it to the encrypt variable, gradually building up the encrypted message character by character. In summary, encrypt equals encrypt double dot cipher ensures that each encrypted character is added to the encrypted message, ultimately forming the complete encrypted message. The last line will do print the encrypted message to the console.